Welcome to video number 10 in the Using iTrain tutorial series. My name is Bob. We've got a lot to cover in this tutorial, so I recommend settling down with a nice cup of coffee. Welcome back. We're in the layout that we saved from the last tutorial, which was TUT09. In that video, we defined our feedback control objects by setting them all to occupancy sensors and making all the lengths 150 centimeters. In this video, we will be defining our block control objects. Before we get started, let's save this as a new file name. So we go save as, and we'll make this tutorial number 10. Press OK, and then we can open the Switchboard editor by going up to Edit and down to Switchboard. We will start with the block in S1, so we just double click on it to open the Properties window. Here we have the usual format for an editor window, with the name and description at the top, and this time we've got a lot of other options and tabs here. We won't be going through all of the different options, we'll just be focusing on the options that we need for this tutorial series. As usual, the first thing we need to do is give it a name. We'll call this one S1, and the description we'll give is siding 1. In the type, we select the type of block we want this to be, and this will be a siding because we've got the buffers at the end of it. We have a siding, so we select siding here. The length is already showing at 150 centimeters. That was picked up by iTrain when we defined the feedbacks and grouped it with this block here. If yours has no length in it, press this Autofill button down here and it should update it for you, or just double click on it to enter it manually. Regardless, you should get in the habit of pressing the autofill button when you enter the block editor here, because that also updates these parameters in the feedbacks and the 2 direction tabs as well. And now we can work along these tabs in order here. For the gauge, we'll leave it at 00. The electrified we will untick for the moment, and in the direction we will select bi-directional because we're in a siding and the traffic needs to flow in and out of the siding. All these other parameters we can leave at default. In the block control, we set the interface that we're using, and then everything else we can leave as their default settings. And then if we go up to the feedback tab, we'll see that the data has been automatically entered. Again, if yours is not showing anything, click the autofill button and this should then show data. What we are seeing in this column is that the feedback center is S1 with the address of 1. And we can see that its length is 150 centimeters and its position in the block in the direction next is from 0 to 150 centimeters. So it's spanning the whole length of the block. And because we have only one sensor in this block, the same span is shown in the direction towards previous. If you had 2 occupancy sensors in the block, the setup would look something like this. When we defined the feedback sensors, we would have made their lengths 75 centimeters each instead of 150. And this sensor, for example, would have been starting at 0 centimeters, and this sensor number 2 would be starting at 75 centimeters. So the setup would be like this. The whole block here is 150 centimeters long, and we have two feedback sensors in it, feedback 1 and feedback 2, and we're looking at this from the direction next, pointing this way. And feedback 1 would be starting at 0 centimeters and stopping at 75, and feedback 2 would be starting at 75 and finishing at 150, which is what we are showing here. If you want to enter these measurements manually, you can double click on them and type them in. You just need to enter the start positions, and then iTrain will automatically fill everything else for you. Now, what is very important is that these feedback sensors are entered in the correct order, which needs to be from previous to next. If they are in the wrong order, you can change the order by clicking on them and then using the move up or move down buttons to correct it. If you're using light sensors or reed switches as your feedback sensors, then your setup could look something like this. There's no length for these type of sensors. All you need to do is enter the exact position along the block. So in this column, from previous to next direction, the start position would be, for example, at 5 centimeters. You just type that in. iTrain will automatically add the rest for you and do the same for the position of your second sensor. So here we've got one sensor at one end of the block and then another sensor at the other end of the block. And here again, we need to ensure that they are entered in the correct order from previous to next. So back to our layout, and we'll go to this tab called Direction Previous. Because we are using occupancy sensors, we have this tick box here called Use Positions. It is ticked by default, and it's important to ensure that it stays clicked, because this enables iTrain to use distance over time measurements to create accurate stopping and brake positions. Release by feedback we will leave unticked, and then down in this section here called Signals, we can leave these in their default settings because we're not using signals at the moment. And because we have a relatively short block length of 150 centimeters, there is no need for us to put a brake position in at the moment, but we do need to enter a stop position. This tab here is for the direction previous, so it would be in this direction from right to left, opposite to the direction the arrow is pointing in. So we have previous over here, next over here. So if we're traveling towards previous, we'd be moving this way, and the stop position would be here by the buffer. And we can enter the length here using either positive numbers, which would be the measurement from the start of the block here over to the end of the block. So for example, if we want to stop the train 5 centimeters from the end of the block here, we could either put a positive number of 145 centimeters, which would place it here, or we could enter a negative number, which is perhaps the more intuitive way of doing it, where we're saying that the stop position is 5 centimeters from the end of the buffer. So we would enter -5 in that instance and press enter. And this block section here is referring to the neighboring block in the direction previous. So that would mean the block that would be over here towards previous. Now in this example there is no block over here because we've got a buffer, and so there's no need to put any data in here, and iTrain has correctly said there is no block in that direction previous. And then we need to do something similar in the direction called next. So in this tab we are seeing it from the point of view of the train moving from left to right in this direction, in the direction of the arrow. So the stop position in this case would be as we're moving along here and stopping just prior to the turnout. This time the start of the block is on this side and the end of the block is over here. So to stop the train 5 centimeters short of the turnout here, we can put a figure of -5 in the stop window and press enter. And this time in the block section here we can see that iTrain has entered this information about the turnouts. And again, if you're not showing anything here, press the autofill and iTrain should fill this out for you. But what it is showing is in the direction next, which would be this direction again, it is showing the objects that iTrain sees after this block that we're in and moving towards the direction next. Now, an important tick box in both of these tabs, so in the direction previous and in the direction next, you'll see this box called critical. This provides an important function in preventing deadlocks in certain situations. If it is ticked, what it says to iTrain is that this block S1 is playing a critical role and should only be reserved if the block that follows it can also be reserved. In our little test track here, a good example of a critical block would be this section of track between the two turnouts here. If it was long enough to be able to create a block and for trains to be able to stop in it. Because if a train was able to stop in this block or reserve that block, it could potentially prevent trains from departing from these sidings, for example, and therefore cause a deadlock. If a train was coming in this direction and stopped in this block here, and all of these blocks here were occupied, there would be a deadlock because this train can't enter any of these blocks, they're occupied, and the trains in these blocks can't get out because this block is occupied. A good analogy of a critical block is the yellow junction box at a road junction here. The rules of the road for a yellow junction box is that you should not enter the box unless your exit is clear. And that is similar for the critical blocks in iTrain. So this is maybe a way to help you identify blocks which are critical. In our little test track here, none of the blocks are critical, and this section of track in the middle here is too short to be a block. In fact, it doesn't exist on our actual railway. So that is all we need to define our blocks. And remember, autofill is your friend here. Remember to click on it so that iTrain automatically fills the data for us. And now if we go to the block tab in the browser here, we can see that block S1 has been created. And if we look at the switchboard, we can see that the block element has changed to a diamond shape to indicate that this is a siding type of block. And we can see that the direction arrow has now changed to a bi-directional arrow with two arrows showing. Here again we can use templates to create the other control objects. So we left click, select template, and we'll change the number to a hash and this number to a hash. We keep them all as sidings. The range will start at 2 and this time finish at number 6. We don't want to correct the existing one, block 1, S1. So then we just click OK, and there we can see all the control blocks for these 6 blocks are being created. And then we can assign the control object to the block by clicking and dragging it. So S2 down to the block that we want for S2. Then if we double click on it, we see the name has been created for us. It has used the siding. We can now press the autofill button to automatically enter the data in here and these other tabs which are currently showing nothing in them. So if I press the autofill now, you'll see that the data has been added, the length has been added as well. Let's do this in order. We'll start in the Options tab. We see that all of this has remained as per block 1, which is good. The feedback has all been entered correctly, length 150. We go to the Previous tab, which is the direction here next to S2, which is no block, which is correct. We need to enter a stop position, which we will make -5. So our stop position will be here, 5 centimeters short of S2. And we can press enter and we can have a look at the next direction, which is this direction here. And all we need to do is create the stop position here. And we will make that -5 also. Press return. And in the block section here, we can now see that iTrain has created the information on what is following from this section, which is all correct. So we can press OK to that. And then we repeat that for S3. We'll drag it down to S3, double click on it, see that the name is correct, the siding. We'll press autofill, it has added the length. We look at the options, they're the same. Feedback is correctly entered. Previous tab, use positions, is ticked. All we need to do is put -5 in the stop, return, and do the same for the direction next, -5, and enter. And this time you can see that in the next direction there is no block, because this is the direction of travel in this particular block. We can see we're traveling this way to next. There is no block following it. And if we looked at the previous tab, it is now showing the information of what iTrain sees if it was traveling in this direction. So we can press OK to save that. And then we'll do the same for S4. Drag that onto there, double click on it. We see that the names are correct, the siding type. We press autofill, move to the options tab, that should be the same, which it is. Feedback is correct, previous. So all we need to do is enter the stop position, -5, return, and the direction tab, -5, return, and then we can click OK. And for the west and east blocks, we can assign the control blocks the other way, which is by double clicking on the block. You then get a blank block, and then you select the block from going to this tab clicking on that, then selecting it from the list that we've created. We click the autofill to fill out the data. Just run through the tabs again to make sure they're all correct. We need to put -5 in here, return, and -5 in there, return, and then we can click OK. Then we can do the same for the last block. We'll double click on it and we'll go to the board item, select it from the list, which is S6, and then we press the autofill, and then all we need to do is enter the -5 for the stop here and the -5 in the direction next, and then click OK. Another thing I'll quickly show you, if you double click on the block and then go to the board item, firstly you see a pictorial diagram of the group that makes up the block, but also you have this box here called text direction, and this allows you to change the way that the text is displayed in the block. So if you had vertical tracks, you could have the block text displayed as per these diagrams here. Good. So now that we've finished defining everything, the next important step is to press this connect button up here. And you'll see a list of the interconnections that iTrain has made. And all we need to do is highlight them and then press the OK button. A simple step, but something you should always remember to do after you've created everything. Then we can press save to save it to the layout, and then press the OK button to exit the switchboard editor. So let's now run the diagnostic again to see if we've created any errors. So up to the view menu to diagnosis, we click on it, and good. No, all we have is the 2 errors that we had there previously. So we created no errors whilst defining our blocks. So now's a good time to save the layout again. So we'll just go up and click the save button. We've saved it as tutorial 10, and now we're ready to run some trains. And that's what we'll do in the next video, when we'll use the drag and drop method to move trains from one siding to another. See you then. Take care.